Hello everyone, I'm Paul. I'm working at Nano and Pico Characterization Lab, mainly located in the B139. After a quick review presentation for 5 minutes, if you are interested to learn more about us or to see all our equipment, please stop by in B139 during the lab tour sections. So at MPC, we specialize in surface analysis such as the size, shapes, height, and depth profile, roughness, as well as mechanical, electrical, magnetic property using the scanning probe microscopes. And also we have a size analysis and element analysis for those applications at the bottom of the center. And we have three full-time staffs, the Adam, the director, and myself to provide the training and technical support, and Mike to focus on the bio AFMs. So we offer the consulting of the design of the experiment or research, and also the training, in addition to also assistance with imaging or data acquisitions. So here is a snapshot of the all equipment we have at MPC. So we have three different type of the SPMs for different applications. And also we have a DLS and NTA for size distribution, surface charge, and counting number of the particle analysis. And ICP, OES, and MS for elemental analysis. And rear mirror is for the mechanical property analysis, such as the viscosity, physicoelasticity, or shear stress. So I would like to introduce the three practical example how we can support your research using the equipment at MPC. The first example is microelectronics. So here is some example of the sample, the single layer of the molybdenum disulfide. So by utilizing the SPM or AFM, you can analyze the shape of the sample, which shows the triangle shapes. Also measure the thickness of the thin film, showing around the 7.5 angstroms. And not only that, also we can create the 3D images by using these AFMs. On top of this, another advantage of this AFM is we can analyze the different type of the characteristics, such as the mechanical or electrical magnetic property. In this case, is a piezoelectricity. So by using this AFM, you can obtain the IV curve with applying different amount of the force. So you can see the IV curve is shifting. The slope is different depending on the force we are applying on the surface. So based on this application, we can measure the different electricity, which is a piezoelectricity, the property using these AFMs. Another advantage we want to highlight is biomechanics. So we have a bio AFMs, which called this a nano wizard, integrated with the confocal microscopes. So this bio AFM is specialized to take three different type of the images. The first one, number one, is optical images, confocal images, another scanning probe microscope images. By utilizing this one, we can see overview of the tissue sample with the optical microscope, and we can identify the different area of the tissue, which is this green is collagen from the tendon, and this dark pink is from the elastin from the bone tissue samples. So we can identify different area using the confocal microscope. Also, we can overlay or mapping the scanning probe microscope images to see the different topographic information about the size, height, and depth profile. And the beauty of this BioFM is we can add additional information such as the stiffness in this case. So you can see there are black line represent the different soft tissues between the junction of the tendon and the bone tissue samples. The last example we want to highlight is the drug delivery. So when you're working on the nanocarrier for chemo or immunogenic the drugs, you can use the DLS or NTA to analyze the size distribution or surface charge to optimize your experimental condition or parameter to enhance your bioavailability or the stability of your nanocarriers. Not only that, also you can use the ICP, OES, or MS to track down drug releasing profile over the time in the different medium. Also analyze the different type of the tissue to understand how this drug is spread in the body, especially for the tumor site. This is an overview of the MPC, the tech centers. I understand you may have a lot of the question about the MPC, how we're doing. So please again stop by the B139 during the lab tour section, or send an email at mpc@cnsi.ucla.edu, or scan this QR code to get the more detailed information. Thank you for your time and attention.